Hello everyone, myself Dr. Lakshmi Soujanya. I am working as an associate professor in the Department of Mathematics, Marri Reddy Institute of Technology and Management. Today I am going to discuss about the concept of differential equations. In this concept, I will cover the following concepts. Like first, initially we will discuss some introduction on differential equations. Later we will see some methods to solve the differential equations. Here the methods we are discussing are exact differential equation. Similarly, methods to solve a non-exact differential equation, Bernoulli's and linear differential equations of first order, next orthogonal trajectories, Newton's law of cooling and law of growth and decay. So, in all these concepts, the main motto you have to know how we can define the differential equation, what is the differential equation, similarly where we can apply the differential equations. So, here differential equation means an equation which consists of differential coefficients is called as a differential equation. Like if I am taking an equation of the form some dy by dx equal to e power x. Here dy by dx is a differential coefficient. Derivative of y with respect to x is a differential coefficient. So if we are having this total is in this equation we have dy by dx as a differential coefficient. So this is a differential equation. Similarly, we can take some d square y by dx square plus some dy by dx whole square into x plus x square equal to 0. Here I have two differential coefficients. D square y by dx square is second order differential coefficient. Dy by dx is first order differential coefficient. So since it has two differential coefficients in this equation, this is also a differential equation. Like that we can define several differential equations with different types of differential coefficients. Here when you are defining the differential equation, we are getting two types. Here I am taking first order differential equation. Here I have second order and first order. So basing on the order, highest order of the differential equation, we can define the order and the degree of the differential equation. The order of the differential equation is the order of highest derivative in the differential equation. See here the order of highest derivative. In this total equation, the highest derivative is first order only. So this equation is at order, the order of this equation is 1. Similarly, in this equation, the highest order is second order differential coefficient. So here the order of this differential equation is 2. Similarly, we can define degree also. Degree means there is a degree of the highest derivative in the equation. For degree, you have to focus on the degree of highest derivative. Here highest derivative is first order and its degree is clearly 1. So this degree of differential equation is 1. In this case, highest derivative is second order. Here the degree is 1. For second order differential coefficient, the degree is 1. So here for this equation, the degree of the differential equation is 1. Even though I have degree 2, highest degree 2, but we will focus on the degree of the highest differential coefficient only. That is the degree of the differential equation. This is the basic definitions of the differential equation. But sometimes basing on the number of independent and dependent variables, whenever we are defining one differential coefficient of the form dy by dx, here x is must and should be independent variable and y is always dependent variable. So with differential coefficient, always you need one dependent variable, at least one or more dependent variables, and similarly we require one or more independent variables also. So basing on the number of independent variables, we can classify the differential equation to two types. One is ordinary differential equation, second one is partial differential equation. Ordinary differential equation means here the equation has only one independent variable, or else the differential coefficients in the differential equation must and should be has only one independent variable. That type of differential equation is called as ordinary differential equation. See, all these previous examples are come under ordinary differential equations. Why? Because here I have only one independent variable x only. So that's why these are come under ordinary differential equations. In case of partial differential equations, the differential coefficient may has more than one independent variable. So since we have more than one independent variable, there we can't take ordinary differential coefficient term d by dx form. You have to use partial differential coefficient of the form dou by dou x. For suppose if you have any function of variables y and z, that means here y and z are independent variables, then Then we can define the partial differential equation as a form dou f by dou y plus some dou f by dou z is equal to some constant or 0 or anything. So this type of form is called as partial differential equation. Similarly, we can take second or third or nth order partial differential equations also. So these two are different types of differential equations basing on the number of independent variables. One is ordinary differential equation, that means it has only one independent variable. Partial differential equation means it has more than one independent variable. Other than these two, basing on the type of function also, we can define four more differential equations. One is linear differential equation, second one non-linear differential equation, third one homogeneous differential equation, and fourth one is non-homogeneous differential equation. So we will see these methods, these special type of differential equations in the coming concepts. Since we have some concepts on linear differential equations and non-linear higher order linear differential equations also. So we will see these concepts at that time. So now the basic types of differential equations is only ordinary and partial differential equations. Ordinary means it has only one independent variable, partial means it has more than one independent variable. Now when you are taking some differential equation, you need to calculate the solution for that differential equation also. For suppose I am taking a simple differential equation of the form dy by dx equal to some x by y. So to solve this differential equation, I will go with the basic method, variable separable method. You just separate y terms and x terms here. Take y term to left side and x term to right side. Then this is y into dy is equal to x into dx. When you are taking integration on both sides, here you will get integral y dy equal to integral x dx plus some integral constant c. So integral of y means that is y square by 2 equal to integral of x is x square by 2 plus c. See, in this differential equation, on solving this differential equation, here I have one arbitrary constant. When solving the differential equation, if the number of arbitrary constants in the solution are equal to the order of the given differential equation, that type of solution is called as a general solution. See, here the order of the differential equation is 1 and also I have one arbitrary constant. That means this one is called as a general solution. So we have another type of differential solution also, that is particular solution. Particular solution means, for suppose for the same equation dy by dx equal to x by y, if they mention any boundary conditions like y of 0 equal to 1, some initial conditions or boundary conditions, whenever they have given some particular conditions, there you have to evaluate this arbitrary constant also. That means on solving this differential equation, we got this solution, that is y square by 2 equal to x square by 2 plus c. Now use this condition in this equation. Here x value is 0, y value is 1. If you are taking these values here, y is 1, so this is 1 by 2 equal to x is 0 plus c. So the integral constant c is 1 by 2. Now use this integral constant here, then you will get the final solution as y square by 2 equal to x square by 2 plus 1 by 2. That means simply y square equal to x square plus 1. These type of solutions are called as particular solutions. That means if you are simplifying the arbitrary constant by using any initial condition in the general solution, that gives your particular solution. So these are the basic types of solutions for the differential equation. Basing on the given equation, you will get the required solution either in form general solution or in the form of particular solution. Initially, you will get the general solution. That means when you are solving the differential equation, always you will get some integral constants. And that too, this number of integral constants that depends on the order of differential equation. Once you got the general solution, if you have any initial condition, you can use that initial condition in the general solution to get the particular solution. So these are the basic concepts of differential equations. Now you have to know how we can use the differential equation, or else how we can apply the differential equation to real life. Here I am taking one simple example. I am taking one circuit. This is the LR circuit. In this circuit, here I indicates the current. and this is a voltage, and this one is resistance, and this one is inductance. So to simplify, to know characteristics of this circuit or to simplify this circuit, we have to use one law, that is Kirchhoff's law. And here Kirchhoff states that the sum of all voltage drops in any closed path of a network is always 0. So he is stating that if you have any closed path of a network, the sum of voltage drops in that network is always equal to 0. How many voltage drops we have here? At the resistance we have one voltage drop. When the current is passing through the resistance, some voltage will be dropped at that resistance. Similarly, at inductance also there is a possibility of losing some voltage. So, and by calculating all this sum, by adding all these voltage drops, that value is must and should be equal to 0. So here I will represent the voltage drop at resistance as VR. VR is the voltage drop across resistance. VL is the voltage drop across inductance. So now according to Kirchhoff law, we can take this value as VR plus VL, and here also we have voltage and it was in negative direction, so that's why we can take minus V equal to 0. So totally we have three values, VR plus VL minus V equal to 0. Now voltage drop at resistance is always equal to current into corresponding resistance value. Voltage drop across inductance is always equal to current into inductance into the rate of change of current, di by dt. Now substitute these values here. VR is I into R plus VL is L into di by dt minus V equal to 0. Now I am simplifying this equation. I will take V to right hand side, then this is L into di by dt plus I into R equal to V. Now divide the total equation with the inductance L, then di by dt plus R by L into I equal to V by L. So this equation is clearly in the form of first order linear differential equation. The first order linear differential equation form is some dy by dx plus p of x into y equal to q of x. Now here y is your current I. In place of x with respect to t we are taking the rate. Next p of x is your R by L form, and corresponding y is again I, V by L is your q of x form. So like that clearly this equation is in the form of first order linear differential equation. So by using the procedure of first order linear differential equation, you can simplify this equation and you can find out the corresponding current which is required, which is possible to pass this circuit. So like that, the simple circuit, we can take LCR circuit also. In case of LCR circuit, we will get another form. So we will get another voltage drop also. So there you will get second order differential equations, or else we can take sequence of circuits also. In case of sequence of circuits, you have to define sequence of differential equations. So basing on the type of circuit, you can define that type of differential equation. So to solve those differential equations, you have to know the basic methods for solving the differential equations. That we will see in the next session. Okay, thank you.